In this video, we shall discuss problems on calendars. First, we shall discuss the concept of a leap year. Any year which is not a century is a leap year if it is divisible by 4. In the case of a century, every fourth century is a leap year and no other century is a leap year. Note, a leap year has 366 days and an ordinary year has 365 days. In a leap year, the month of February will have 29 days. Let us see some examples. Consider the year 1986. First of all, note that the year 1986 is not a century. So, we go for checking whether the year 1986 is divisible by 4 or not. The number 1986 is not divisible by 4. So therefore, we conclude that the year 1986 is not a leap year. To check whether a number is divisible by 4 or not, it is enough if we check whether the last two digits are divisible by 4 or not. For example, in 1986, the last two digits are 86. We find that 86 is not divisible by 4. Hence, we can say that the entire number 1986 is not divisible by 4. Likewise, we find that the years 1742, 1833, 2018 are not leap years. Note here that each of these years is not a century first of all, and each number is not divisible by 4, and hence each of these years is not a leap year. Consider the year 1992. 1992 is not a century. So we go for checking whether the number 1992 is divisible by 4 or not. We find that 1992 is divisible by 4, and hence we conclude that the year 1992 is a leap year. Here also, to check whether 1992 is divisible by 4, we take the last two digits, that is 92. We find that 92 is exactly divisible by 4. So therefore, the entire number 1992 is also divisible by 4. Likewise, each of the years 1756, 1804, 2020 is a leap year. We find that each of these years is not a century, and each of these years is divisible by 4, and hence they are leap years. Now let us look at examples of years which are centuries. The years 400, 800, 1200, 1600, 2000, 2400 are leap years, as we find that each of these years is a 4th century. Remember the note which we have discussed. every fourth century is a leap year and no other century is a leap year. An important note, if the given year is a century, we don't check for its divisibility by 4. Though a given year which is a century is divisible by 4, it need not be a leap year. For example, consider the year 1800. 1800 is a century. Since it is a century, we don't go for checking if 1800 is divisible by 4 or not. Just we check if 1800 is a 4th century or not. We find that 1800 is not a 4th century and therefore the year 1800 is not a leap year. Likewise, the years 100 AD, 1900 AD, 2100 AD are not leap years, as each of these years, which are centuries, are not 4th centuries and hence they are not leap years. Using Zeller's rule, we are going to find the day of the week for any given date. Zeller's rule is used to find the day on any particular date in the calendar in history. This is the formula. F equals K plus 13 into M minus 1 divided by 5 plus D by 4 plus C by 4 minus 2 into C. Here we find that the expression 13 into M minus 1 divided by 5 is enclosed in brackets. That means in the value of the expression you have to take only the integral part and you have to ignore the fractional part. That means whatever comes after the decimal point has to be ignored. Or in other words, it is enough you write the quotient. Here K stands for the date, M is the month number, D stands for the last 2 digits of the year and C is the first 2 digits of the year. Rules in applying Zeller's formula. The year begins with March and ends in February. It is not like our regular calendar. In Zeller's rule, the year begins with March and each month will have a number associated with it. Since the year begins with March, the month number for March is 1 and for April it is 2, for May it is 3 and so on up to January, which will have the number 11 associated with it, and for February the month number is 12. January and February are counted as the 11th and 12th months of the previous year. For example, January 2016. In this case, the month number is 11 because 11 is the number associated with the month of January. Since January and February are counted as the 11th and 12th months of the previous year, the year should not be taken as 2016. It has to be taken as 2015, the previous year. While calculating, we drop off every number after the decimal point. Once we have found the answer, we divide it by 7 and take the remainder. Remainder 0 corresponds to Sunday, remainder 1 corresponds to Monday, remainder 2 corresponds to Tuesday, and so on. If the remainder is negative, then we have to add 7. You can understand these rules when we solve problems. Here is a table which we have to remember. If the number of days is 0, then it corresponds to Sunday. If the number of days is 1, it corresponds to Monday. If it is 2, it is Tuesday, and so on. Type 1. Finding the day of the week for a given date. Find the day of the week on 29th June 2020. Zell's formula is F equals K plus 13 into M minus 1 divided by 5 plus D by 4 plus C by 4 minus 2 into C. Here K equals 29, the date, M equals 4, the month number. The month number for March is 1, for April it is 2, for May it is 3, and for June it is 4. D is the last two digits of the year. The year is 2020, so the last two digits is 20, so therefore D equals 20, and C is the first two digits of the year, again it is 20. We substitute the values in the formula. F equals 29 plus 13 into 4 divided by 5 plus 20 plus 20 by 4 plus 20 by 4 minus 2 into 20. That equals 29 plus, we apply the BODMAS rule. So first we calculate 13 into 4, that is 52. 52 minus 1 is 51 divided by 5 plus 20 plus 20 by 4 is 5 plus 20 by 4 is again 5 minus 2 into 20 is 40. That equals 29 plus, since 51 divided by 5 is enclosed in brackets, we have to take only the integral part, or in other words, you divide 51 by 5 and write the quotient. 10 times 5 is 50, so 10 is the quotient, so I put 10 plus 20 plus 5 plus 5 is 10 minus 40. Or see here, in the expression 51 by 5, the value of this expression is 10.2. The integral part is 10 and the fractional part is 2. Whatever comes after the decimal point is considered to be as the fractional part. That has to be ignored. So that's why we take only 10. That equals, I put 1. So it's an important step here. In the place of 29, I put 1. Because whenever I get a number greater than or equal to 7, you divide the number by 7 and write the remainder. Because that makes our calculations simpler. When 29 is divided by 7, 4 times 7 is 28 and the remainder is 1. So 29 can be replaced by 1. And when 10 is divided by 7, 1 times 7 is 7, the remainder is 3. And when 20 is divided by 7, 2 times 7 is 14 and the remainder is 6. Again for 10 I can write 3, and 40, 5 times 7 is 35 and the remainder is 5. So now see here, in this expression 1 plus 3 plus 6 plus 3 minus 5, when you add 1 and 6 you will get 7. 7 means it is 0, because when you divide 7 by 7, the remainder is 0. So whenever you get 7, you can simply ignore that. So in this expression I can ignore that 1 plus 6, so that is 7. So the remaining values are 3 plus 3 minus 5. So 3 plus 3 is 6 and 6 minus 5 is 1. Or you can do in this way. You can straight away take the expression 29 plus 10 plus 20 plus 10 minus 40. 29 plus 10 is 39. 39 plus 20 is 59. 59 plus 10 is 69. 69 minus 40 is 29. Dividing 29 by 7, 4 times 7 is 28 and the remainder is 1. So whatever may be the way you proceed, you will get the same answer. And as per the table, 1 corresponds to Monday. So therefore 29th June 2020 is a Monday. Let us see what is the day of the week on 15th August 1947. ZLS formula. Here k equals 15, m equals 6. 6 is the month number associated with August. C is 19, the first two digits of the year, and D equals 47. We substitute those values in the formula. So that equals 15 plus, see here, 13 into 6 is 78. 78 minus 1 is 77 divided by 5 plus 47 plus 47 divided by 4 is enclosed in brackets. So 11 times 4 is 44. So the quotient is 11. So 47 divided by 4 enclosed in brackets, I put 11. And another expression 19 by 4, it is again enclosed in brackets. So 4 times 4 is 16. So 4 is the quotient. So 19 by 4 enclosed in brackets, the value is 4. And 2 times 19 is 38. So that equals, instead of 15, I can put 1, because whenever I get a number greater than or equal to 7, I divide it by 7 and write the remainder. So 2 times 7, 14, the remainder is 1. And 77 divided by 5. So 15 times 5 is 75. So I write the quotient, I don't bother about the remainder. So 15 plus 47 is replaced by 5. Because 7 times 6 is 42, the remainder is 5. And 11 is replaced by 4, because 1 times 7 is 7, the remainder is 4. And there is another 4 there. And 38 is replaced by 3, because 5 times 7 is 35 and the remainder is 3. So that equals 1 plus, again 15 is replaced by 1, 5 plus 4 minus 3. Now in this expression you find that the value of 1 plus 5 is 7. You just simply ignore that. So the remaining expression is 4 plus 4 minus 3. That is 8 minus 3. 8 minus 3 equals 5. And as per the table, 5 corresponds to Friday. So therefore 15th August 1947 is a Friday. One more example of this type. Find the day of the week on 1st January 2005. So here is the ZLS formula. Here k equals 1, m is 11, because January, the month number is 11. Because January and February are counted as the 11th and 12th months of the previous year, the year given here is 2005. We should not take 2005. We have to take 2004 instead. So therefore, the first two digits of 2004 is 20. So therefore, here C equals 20. And the last two digits in 2004 is 04. So therefore, D equal to 4. So this is the step where we have to be careful. All other steps are the same. And we find that the final value is 6. So 6 corresponds to Saturday. So therefore 1st January 2005 is a Saturday. Let us move to type number 2. In type number 2, they will give you a date and what is the day of the week on that date, and they will ask you to find what is the day of the week on the same date in a different year. For example, here they have asked what is the day of the week on January 1, 2009, and they have given that January 1, 2008 is Tuesday. Here we can make a very simple guess. If January 2008 is Tuesday, then January 1, 2009 will be either a Wednesday or a Thursday. That's the first guess. And we are going to find if January 1, 2009 is a Wednesday or a Thursday. Because naturally, say for example, if Diwali falls on Monday this year, then naturally it will fall either on Tuesday or Wednesday of the next year. So that is the logic behind. So here if 2008, the 1st of January falls on Tuesday, then the 1st of January 2009 will be either a Wednesday or a Thursday. So we are going to determine that. So for that, here you have to make a small note. We pass on from January 1, 2008 to January 1, 2009. As we pass on from January 1, 2008 to January 1, 2009, we should look the year in which we cross the month of February. I repeat, we should look the year in which we cross the month of February. So while passing from January 2008 to January 2009, we come across the month of February in 2008. And 2008 is a leap year, so therefore the month of February will have 29 days. So January 1, 2009 will be 2 days after Tuesday. That means it is Thursday. Can you guess what is the day of the week on January 1, 2010? We know that January 1, 2009 is a Thursday, and we need to find what is the day of the week on January 1, 2010. As did in the previous problem, we pass on from January 1, 2009 to January 1, 2010. We have to look the year in which we cross the month of February. We crossed the month of February in 2009 as we pass on from January 1, 2009 to January 1, 2010. And 2009 is not a leap year. So therefore, January 1, 2009 will be 1 day after Thursday. So that is a Friday. So what bothers in this type of problem is the year in which we cross the month of February. Another example, on 8th March 2005, it is a Tuesday. What is the day of the week on 8th March 2004? So here we travel backwards. We move from 8th March 2005 to 8th March 2004. Here also we have to look into the year in which we cross the month of February. So as we move back from 8th March 2005 to 8th March 2004, we cross the month of February in 2005. And 2005 is not a leap year. So therefore we can conclude that 8th March 2004 will be 1 day before Tuesday, that is a Monday. Of course, we can make an initial guess. It will be either Monday or Sunday. And depending on the year in which we cross the month of February, we decide the day. Right. Can you guess what is the day of the week on 8th March 2003? So as did in the previous example, we move back from 8th March 2004 to 8th March 2003. So before that, let us make an initial guess. 8th March 2003 will be either Sunday or Saturday. And we are going to determine whether it is a Sunday or a Saturday. So as we move on from 8th March 2004 to 8th March 2003, we have to look into the year in which we crossed the month of February. We crossed the month of February in 2004. 2004 is a leap year, so therefore it will be 2 days before Monday. So therefore 8th March 2003 is a Saturday. One more example. If 11th January 1997 was a Sunday, what is the day of the week on 10th January 2000? So we shall go step by step. First we shall calculate what is the day of the week on 11th January 1998, and then what is the day of the week on 11th January 1999, and then what is the day of the week on 11th January 2000. And from that we can find what is the day of the week on 10th January 2000. So first we move from 11th January 1997 to 11th January 1998. In that process, we crossed the month of February in 1997. 1997 is not a leap year. So therefore, 11th January 1998 will be Monday. That is one day after Sunday. So this is the first process. We move from 11th January 1997 to 11th January 1998, in which we cross the month of February in 1997, which is not a leap year. So therefore it is simply one day after Sunday, that is Monday. And now we move from 11th January 1998 to 11th January 1999, in which we cross the month of February in 1998. Again 1998 is not a leap year. So therefore 11th January 1999 will be one day after Monday. So that is a Tuesday. Now we move from 11th January 1999 to 11th January 2000. In this process, we cross the month of February in 1999. Again, 1999 is not a leap year. So therefore, 11th January 2000 will be one day after Tuesday. So that is a Wednesday. Now the question is, they have asked you what is the day of the week on 10th January 2000. 11th January 2000 is a Wednesday. So therefore, 10th January 2000 will be one day before that, so that is a Tuesday. Can you guess what is the day of the week on 10th January 2001? So here we are going to move from 10th January 2000 to 10th January 2001. The initial guess will be either it will be a Wednesday or a Thursday. As we move from 10th January 2000 to 10th January 2001, in the month of in the year 2000, we cross the month of February. 2000 is a century, of course a fourth century, so therefore it is a leap year. So the day of the week on 10th January 2001 will be 2 days after Tuesday, therefore it is a Thursday. So here, when we make a pass from 10th January 2000 to 10th January 2001, we cross the month of February in 2000, which is a leap year. So therefore it is 2 days after Tuesday. We shall go a little bit faster with this example. If January 1, 2006 is Sunday, what is the day of the week on January 1, 2010? So first we shall find what is January 1, 2007. So it will be a Monday because 2006 is not a leap year. And January 1, 2008 will be a Tuesday because 2007 is not a leap year. Now, January 1, 2009 will be a Thursday because 2008 is a leap year. So this is the place where we have to be careful. When we pass on from January 1, 2008 to January 1, 2009, we cross the month of February in 2008. 2008 is a leap year. So therefore, January 1, 2009 will be 2 days after Tuesday. So therefore, it is a Thursday. And January 1, 2010 will be a Friday because we cross the month of February in 2009, which is not a leap year. So it will be 1 day after Thursday. So therefore, it is a Friday. Now we shall move to the next problem. If 28th February 1997 was a Friday, what will be the day of the week on 28th February 1996? So here also we move back from 28th February 1997 to 28th February 1996. As we move back, we step into the 29th of February in 1996. And 1996 is a leap year. So therefore, the month of February will have 29 days. So therefore, we step into that day before stepping into 28th February 1996. So therefore, it will be 2 days before Friday. That is a Wednesday. So when moving back to 28th February 1996, from 28th February 1997, we step into the 29th of February in 1996. So hence 28th February 1996 is 2 days before Friday. So that is a Wednesday. Can you guess what is the day of the week on 28th February 1995? As we pass or move back from 28th February 1996 to 28th February 1995, of course 1995 is not a leap year, so therefore no problem at all. So therefore it is simply 1 day before Wednesday, so therefore it is a Tuesday. Let us move to the next type. In this type, they will give you a reference date and what is the day of the week on that date, and they will give you another date in the same year and they will ask you to find what is the day of the week on that date. For example, if 29th June 2020 is Monday, they have asked you to find what is the day of the week on 14th November 2020. In this case, what you have to do is starting from the next day of the reference date. That means from 30th June 2020 till 14th November 2020, you have to calculate the total number of odd days. I repeat, starting from the next day of the reference date, that is from 30th June 2020 till 14th November 2020, you have to calculate the total number of odd days. In the month of June, there is only 1 day left. So in June, there is 1 day left. Now we move to the month of July. We have to find what is the number of odd days in the month of July. Here I want to make an important note here. Any month which has 31 days will have 3 odd days. And any month which has 30 days will have 2 odd days. I repeat, any month which has 31 days will have 3 odd days, and any month which has 30 days will have 2 odd days. That's very simple. 31 divided by 7, 4 times 7, 28, the remainder is 3. So that is why for any month with 31 days will have 3 odd days, and any month with the 30 days will have 2 odd days. 30 divided by 7, the remainder is 2. So therefore we say any month with 30 days will have 2 odd days. And February is exceptional. February will have 28 days or 29 days. If it has 28 days, the number of odd days is 0. And if February has 29 days, in the case of a leap year, the number of odd days is 1. Again we write the remainder after dividing 29 by 7. Odd days means those days which cannot be accommodated in weeks. For example, in 31 days, you can accommodate 28 days in 4 weeks. First 7, second 7, third 7, fourth 7 days. So 28 days can be accommodated in weeks and the 3 days are left over. That is what we call as odd days. Right, we come back to the problem. Now you have to calculate the number of odd days in the month of July. July is a month with 31 days. So in July there will be 3 odd days. The next month is August. August is again a month with 31 days. So therefore the number of odd days is 3 again. Next, the month of September is a month with 30 days. So therefore the number of odd days is 2. The next month is October, a month with 31 days. So therefore the number of odd days is 3. And in November, starting from 1st November, it is enough if we move up to 14th November. So therefore the number of days will be 14. 14 divided by 7, the remainder is 0. So 14 days is equivalent to 0 odd days. So here what we have done so far is we have written the number of odd days in each month starting from the 30th of June till 14th November. Now we shall find what is the total number of odd days. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 2 is 9, 9 plus 3 is 12. So the total number of odd days is 12. Again when you divide 12 by 7, the remainder is 5. So 12 days is equivalent to 5 days. And the answer is 5 days after Monday. Please note here, we don't go to the table. In this type of problems, if the given reference date is Monday, and see here in this example you have got the total number of odd days to be as 5. So therefore the day of the week on which 14th November 2020 falls is 5 days after Monday. So 5 days after Monday means Tuesday, Wednesday, Thursday, Friday, Saturday. So therefore the answer is Saturday. Let us see one more example. If 29th June 2020 is Monday, what will be the day of the week on 25th December 2009? Here they have asked you what is the day of the week on a date in the previous year. So here also, starting from 26th December 2019 till 29th June 2020, we are going to calculate the total number of odd days. I repeat, starting from 26th December 2019 till 29th June 2020, we are going to calculate the total number of odd days. We shall go in the reverse way. In the month of June, there are 29 days. So 29 days means it is equivalent to 1 odd day, because 29 when divided by 7, the remainder is 1. So in June 2020, there is 1 odd day. We move backwards. So we move to May 2020. May is a month with 31 days. So there are 3 odd days. We move back. April 2020, there are 2 odd days. March 2020, there are 3 odd days. And February 2020 is a leap year. 2020 is a leap year. So therefore the month of February will have 29 days. So therefore we put 1 odd day, because 29 divided by 7, the remainder is 1. We move back to the previous month. So in January 2020, there are 3 odd days, because January is a month with 31 days. Now in December, it is enough if we calculate the number of odd days starting from 26th December till 31st December. So how many days are there? There are 6 days. So that's it. We have started from 26th December till 29th of June in 2020. We have written the number of odd days in each month. Now we shall calculate what is the total. The total is 1 plus 3 4, 4 plus 2 6, 6 plus 3 9, 9 plus 1 10, 10 plus 3 13, 13 plus 6 is 19, and 19 is equivalent to 5 odd days, because 19 when divided by 7, the remainder is 5. So the answer is, that means 25th December 2019 will be 5 days before Monday. So before Monday means Sunday, Saturday, Friday, Thursday, Wednesday. So if 29th June 2020 is Monday, then 25th December 2019 will be a Wednesday. Let us move to the next type. In this type, they will give you what is the day of the week. Say for example, if today is Monday, and they will ask you what will be the day of the week after some certain number of days. Here they have asked you to find what is the day of the week after 94 days if today is Wednesday. These type of problems are very simple. Just divide the given number of days by 7 and find what is the remainder. So when 94 is divided by 7, the remainder is 3. So the answer is, if today is Wednesday, then the day of the week after 94 days will be 3 days after Wednesday. So 3 days after Wednesday means Thursday, Friday, Saturday. So the answer is a Saturday. Let us see one more example. If today is Monday, what will be the day of the week 350 days from now? As did in the previous example, we divide the number 350 by 7 and find what is the remainder value. 350 is exactly divisible by 7, so therefore the remainder is 0. So therefore 0 days after Monday. 0 days after Monday means it is a Monday again. So if today is Monday, the day of the week after 350 days from now will also be a Monday. Let us move to the last type. Which forthcoming year after 1982 will have the same calendar as that of 1982? So here we have to find which forthcoming year after 1982 will have the same calendar as that of 1982. So for that we have to construct a table with the 3 columns. In the first column we write down the years. In the second column we write down the number of odd days. And in the third column we write the total number of odd days. So we start from 1982. The number of odd days is 1 because 1982 is not a leap year, and the total number of odd days is also 1. Next, the year is 1983. The number of odd days is 1. Look at the second row. 1983 is not a leap year, so therefore the number of odd days is 1. Now the total is 1 plus 1 is 2. That 1 is taken from the total of the previous row, and the other one is taken from the number of odd days in the present row. So 1 plus 1 becomes 2. Next we move to the next year, 1984. 1984 is a leap year, so therefore the number of odd days is 2. Now we write 4 to be the total number of odd days. 2 plus 2 is 4. 2 is taken from the total of the previous row, and the other 2 is taken from the number of odd days in 1984. Next we move to 1985. 1985 is not a leap year. The number of odd days is 1. The total will be 4 plus 1 equals 5. Next year is 1986, again which is not a leap year. The number of odd days is 1, and the total number of odd days will be 5 plus 1 equals 6. Next we move to the next year, 1987, again which is not a leap year. Number of odd days is 1, so 6 plus 1, 7. Now the total number of odd days is 7. Whenever you get a multiple of 7, you have to stop at that stage and you have to check whether the next year has the same calendar as that of the given year. Here we get 7, so therefore the next year 1988 may have the same calendar as that of 1982. It may have or may not have, that we have to decide. Now 1988 happens to be a leap year, but the given year 1982 is not a leap year. So therefore the calendar of 1982 cannot be the same or cannot be the same as that of 1988. So therefore we have to proceed further. So for 1988 the number of odd days is 2 and the total number of odd days is 7 plus 2 equals 9. Next year is 1989, the number of odd days is 1 and the total is 9 plus 1 equals 10. The next year is 1992, which is not a leap year, number of odd days is 1, so 10 plus 1 equals 11. And we go on till for 1992 the number of odd days is 2 because it is a leap year, and we get the total number of odd days to be as 14. So here we have to stop because we have obtained a multiple of 7. And the next year, which follows 1992, that is 1993, may have the same calendar as that of 1982. We find that 1993 is not a leap year and the given year 1982 is also not a leap year. So therefore we conclude that the year 1993 will have the same calendar as that of 1982. I have written the description. We shall see one more example. Which forthcoming year after 2007 will have the same calendar as that of 2007? So we shall start. 2007 is not a leap year, so the number of odd days is 1 and the total number of odd days is 1. Next we move to the next year, 2008, which is a leap year, so therefore the number of odd days is 2 and the total number of odd days is 3. Next year is 2009, which is not a leap year, the number of odd days is 1 and the total number of odd days is 4. Next year 2010, again not a leap year, so number of odd days is 1 and the total number of odd days is 5. Next year 2011, again which is not a leap year, number of odd days is 1 and the total number of odd days is 6. Next 2012, which is a leap year, the number of odd days is 2. 6 plus 2, the total number of odd days becomes 8. See here we did not get 7. That doesn't matter. We have to keep on computing till we get a multiple of 7. So we proceed further. So 2013, the next year, it is not a leap year. So the number of odd days is 1 and the total number of odd days is 9. Next year is 2014, the number of odd days is 1 and the total number of odd days becomes 10. Next 2015, 1 odd day, total 11. Next year 2016, which is a leap year, number of odd days is 2 and the total number of odd days is 13. Next year is 2017, which is not a leap year, number of odd days is 1. Now the total becomes 14, which is a multiple of 7. So we make a stop here. The next year 2018 may have the same calendar as that of 2007. 2018 is not a leap year. The given year 2007 is also not a leap year. So therefore we can conclude that the year 2018 will have the same calendar as that of 2007. So thank you. If you find this lecture useful, press the like button, subscribe to my channel for notification of updates, share this video to whomever it may be useful. Thank you.